So now we're going to talk about the row operations that you can perform on any augmented matrix, okay? Keep in mind, you cannot do anything you want to an augmented matrix. There are 3 specific row operations that you are allowed to perform. Only 3, okay? So the 3 row operations that we are about to talk about, those are the only 3 things that are allowed for operating on an augmented matrix, okay? All right, so let's start talking about them, okay? So this is on page 3 of the notes, okay? At the top, under row operations, okay, again, it says we will solve a system of equations by operating on its augmented matrix, okay? When operating on an augmented matrix, only the matrix row operations listed below are allowed. These matrix row operations result in a succession of equivalent matrices, each representing a system that has exactly the same solution as the original system. Okay, so one more time, when you get your system of linear equations, you are going to translate it into an augmented matrix. Then you're going to use these 3 row operations that we are going to talk about to operate on the initial augmented matrix, okay? That is going to produce a series of different matrices, okay? They are all going to look different, but they are all equivalent to the original system, okay? Finally, you will reach a final augmented matrix. We will talk about how you recognize that a little later, okay? Once you get to the final augmented matrix, you will go ahead and interpret the solution to the system of equations, okay? So let's talk about the 3 row operations that are allowed, okay? Again, cannot emphasize enough, these are the only 3 things allowed, okay? Don't make up your own row operations. All right, so here we go. First thing you're allowed to do, switch any 2 rows, okay? So that's easy enough, okay? Switch any 2 rows. All right, so as an illustration, okay, perform, let's read this. This means row 1, okay? So when you see the R, that means row, okay? So this means perform row 1, switch it with row 2, okay? So that double arrow means to switch, okay? So we're going to take this matrix, we're going to switch row 1 and row 2, okay? The entire row switches, including the numbers on the right side of the vertical line. Okay, so if you perform this row operation, okay, what you would get, the first row, 8, 7, 56, would become the second row. So 8, 7, 56. Okay, and then the second row, 6, 5, 60, would become the first row. And that's it. Okay, you switch the entire rows. Okay. You do need to know how to read this shorthand notation. Okay, row 1, switch with row 2. Okay, you are also going to need to be able to write it down to explain how you go from one matrix to the next. So start paying attention to this notation. All right, so that's the first thing you can do, switch any 2 rows. Okay, next thing, number 2, you are allowed to multiply or divide one of the rows by a non-zero number, okay? Multiply or divide one of the rows by a non-zero number, okay? So as the illustration, we are going to perform, read it to yourself, 2 times the first row becomes the first row, okay? So this single-sided arrow means becomes or replaces. Becomes or replaces. And I guess I'll go back up here and say this double-sided one means switch. Okay. All right. So here we go. Okay. So we are taking the first row and multiplying it by 2. That is going to become the new first row. If you notice, there is no mention of the second row. Okay. So that means the second row is not going to change. So I am going to go ahead and just write down the second row because nothing is happening to it. Okay. And then you're going to multiply the first row by 2. Every number in the first row gets multiplied by 2, okay? So 2 times 3 is 6, 2 times 4 is 8, and then 2 times 24 is 48, okay? So that would be the next matrix in the series, okay? These two are equivalent matrices, meaning the systems that they represent have the same solution, okay? All right, so switch any two rows, multiply or divide one of the rows by a non-zero number. Real quick, before we talk about the third one, when you do this particular operation, okay, if you multiply row 1 or divide by a number, it has to replace row 1, okay? You cannot multiply or divide row 1 by something and then use it to replace row 2. Cannot do that, okay? Whichever row is being multiplied or divided by something, it has to replace that row. So keep that in mind. All right, number 3 may be the trickiest to understand, but it is going to be the most useful one of the 3 operations, okay? You are allowed to replace a row by its sum or difference with a multiple of another row, okay? That's a lot to take in, okay? Replace a row by its sum or difference with a multiple of another row, okay? So let's look at the illustration. We've got an augmented matrix here, and this is what we're being asked to perform, okay? So we're replacing a row. Here we're replacing row 1, okay? We're going to replace row 1 by its sum or difference, okay? So we're adding or subtracting row 1 with a multiple of a different row, okay? So basically, what I'm doing here, since I want to replace row 1, okay, I am going to multiply some other row by something, by some number, and then add it back to row 1, okay? And then that is going to be my new row 1, okay? All right, so let's try that here, okay? Like I said, this is going to be the one, this is going to be the row operation you're going to use the most, okay? It may not make a lot of sense right now, but as we start getting into working with the matrices, you will hopefully pick it up, okay? So let's just go ahead and do what this says, okay? So again, this is the operation. It is going to replace row 1. So once again, I am doing absolutely nothing to row 2. So I'm going to leave it alone. Okay. So now I've got to replace row 1. Okay. This tells you what to do. We are going to go to row 2. I'm going to do the workout to the side. We're going to multiply everything in row 2 by -3. Okay. So row 2 is 2, 2, -4. Everything has to get multiplied by -3. So that's going to be -6, -6, +12. Okay. And now we're going to add that result back to row 1. Row 1 is 6, 5, 60. Okay. So add -6 plus 6 is 0. -6 plus 5 is -1. 12 plus 60 is 72. That is going to be your new first row. Okay, so 0, -1, 72. Okay, so again, these two row operations are equivalent, or sorry, the row operation that we just performed, we got a different looking matrix, but these two matrices are equivalent. They represent the same system of linear equations, you know, so it will produce the same solution to the system of equations. Okay, all right, so again, these are the 3 row operations you are allowed to do. Switch any 2 rows, multiply or divide one of the rows by a non-zero number, replace a row by its sum or difference with a multiple of another row. Okay, this is going to be the one you use the most. Might be a little tricky to understand right now, but as we do the practice, you'll pick it up. Okay, at the bottom, I kind of summarized the notation you saw when we're doing this, because I do want you to write your notation out of your operations, how you go from one matrix to the next. Okay, R means row. A double-sided arrow means to switch with. You switch the 2 rows. And then if you see a single-sided right arrow like this, that means becomes or replaces. Okay? All right. So let's go ahead and try some of these row operations. Okay? So I am going to get the next example out where we can practice some of these row operations. Okay? All right. So in example 4, okay, I give you a matrix, okay, and it says perform the indicated row operations on the given matrix. If an operation is not a valid row operation, state not valid, okay? Because remember, those three things we just talked about, those are the only three things allowed. So if something is presented here that does not include one of those three things you discussed, you have to write down not valid because you can't do it, okay? All right, so here we go. We've got our matrix. In part A, you are asked to do this, okay? So if you read this, this is switching row 1 and row 2, okay? So let's write the new matrix, okay? So this first row will become the second row. So 2, -4, +6, okay? First row became your second row. And now the original second row will become the first row, okay? And that's it, okay? We just performed that row operation on the augmented matrix. It's valid because you're allowed to switch any two rows, okay? All right, the next one, okay? Again, we are clearing the slate, okay? Part A was part A, okay? So ignore it. We're going back to the original augmented matrix, okay? Every time we do one of these parts to the problem, we're going back to the original augmented matrix to operate on it, okay? We're not operating on the previous one, is my point, okay? All right, so part B, okay? -1/2 times row 1 becomes row 1, okay? This is a valid row operation. It's number 2. We are multiplying one of the rows by a non-zero number, okay? All right, so again, when you read this, we're multiplying row 1 by -1/2. That's going to replace row 1. Okay, remember, if you're multiplying a row by a number, it has to replace that row. Okay, so for example, if this had said, take this and replace row 2, that would not be valid. Okay, all right, again, there is no mention of row 2, so we're going to leave row 2 alone. 1, -3, 5. Okay. And now we're going to take row 1, okay? I'll go up here and do some work. If you can do this in your head, that's fine. All right, so you're going to take everything in row 1. This is the current row 1. You're going to multiply everything by -1/2, okay? So you have to kind of distribute here, okay? So that's going to give you -1/2 times +2 is -1, and then -1/2 times -4 is +2. And then -1/2 times 6 is -3, okay? So this would become your new first row. And then that's it, okay? That would be the new matrix, okay? All right, so moving on, okay? Let's go to part C, okay? Again, we are going back to the original augmented matrix presented in the problem. You're asked to do 0 times row 2 becomes row 2, okay? This is not valid. You're multiplying row 2 by something, but you're multiplying by 0, okay? That is not allowed, okay? Why is that not allowed? Because if you multiplied row 2 by 0, the second row would just become 0, 0, 0, okay? And can't do that, okay? You can have a row of zeros in a matrix. That is possible, okay? But by multiplying the row by 0, you're essentially wiping out the equation, okay? So you're not allowed to do that. Okay, so we're just going to write here, this is not a valid row operation. All right. Okay. D. Okay. Are you allowed to take the original augmented matrix and do 5 times row 1 becomes row 2? Okay. This is not valid. Okay. Yes, you're allowed to take row 1 and multiply it by 5, but that would have to replace row 1. It cannot replace row 2, okay? You could have also done 5 times row 2 becomes row 2, okay? But as it's written, this is not a valid row operation, okay? So, I'm going to put on here valid row operations include, okay, so things we could have done instead, we could have done 5 times row 1. That could have replaced row 1, okay? Or we could have done 5 times row 2 and had that replace row 2, okay? But this particular thing as it's written is not valid. Okay, let's look at E and F together here because I want to make a comment here, okay? Part E is saying add rows 1 and 2, and that's going to replace row 2. And then in part F, it's talking about let's subtract 2 rows, and that'll become row 1, okay? So in part E, you're adding 2 rows, and in part F, you're subtracting 2 rows. Is that allowed? Okay, well, let's go back to our rules over here. Okay, again, let's look at this one. This is the one, like I said, that's the big rule here. Okay, replace a row by its sum or difference with a multiple of another row. Okay, so when I look at E, okay, I am replacing row 2. Okay, I'm allowed to replace row 2 by its sum with a multiple of another row. Okay, so if I'm replacing row 2, I'm allowed to replace row 2 with the sum of itself and a multiple of another row. Well, this is a multiple of another row. It's 1 times row 1. Okay, so you are meeting the criteria for operation number 3. We are taking row 2 and replacing it with its sum with a multiple of another row, okay? So what this tells us in example E, we are allowed to add 2 rows at any time, okay? You are allowed to add any 2 rows, okay? Similarly, over here, okay, you're subtracting 2 rows. Is that allowed? Well, I'm replacing row 1 here. So again, according to operation number 3, I'm allowed to replace row 1 with itself plus or minus a multiple of another row, okay? So this is really row 1 plus a multiple of another row, okay? If I took row 2 and multiplied it by -1, that's a multiple of another row, and then I'm adding it back to itself, okay? So this is a valid row operation. So what you need to get out of E and F before we actually even do it, okay? This is big. This will help you a lot, okay? You are allowed to add or subtract 2 rows. Oh, I wrote 2 twice. You are allowed to add or subtract 2 rows. Okay, you're allowed to add or subtract any 2 rows. Okay, it is a consequence of that 3rd row operation. Okay, it's allowed. Okay, so let's go ahead and do it. Okay, all right, so I'm going to go ahead and take this off. I don't want to confuse you. Okay, all right, so we're going back to the original matrix up here. Okay, we are going to replace row 2. Okay, so because of that, okay, I'm going to leave row 1 alone. Row 1 is 2, -4, 6. Okay, and then to get the new second row, you need to add the elements in rows 1 and 2. Okay, so again, I'm going to add here 2. Here, let me do the work. Well, I'll do it over here. Okay. So if we add, here we go. Let me just do it this way. So 2, -4, 6, 1, -3, 5. Okay, there's row 1 and row 2. We're just adding everything. Okay, so if we add 2 plus 1 is 3, -4 plus -3 is -7, 6 plus 5 is 11. Okay, that is your new second row. Okay, and that will be your new equivalent matrix. Okay. All right, example F. Okay, example F. Row 1 minus row 2 becomes row 1. We've already discussed this is valid. Okay, we are replacing row 1. So I'm going to go back to the original matrix up here. Okay, I'm going to go ahead and write down row 2 because it is not changing. And then my new first row, how do I get that? Okay, I'm going back to the original matrix. I'm writing down rows 1 and 2. And you are subtracting them here. You need to be careful with your signs, okay? 2 minus 1 is 1. -4 minus -3, okay? -4 minus a -3, okay? Minus a minus becomes plus a positive, okay? So that's going to give you -1, okay? And then 6 minus 5 is 1, okay? So this is going to be your new first row, okay? So there's your new matrix, okay? You are going to do a ton of subtracting a negative. You've got to be careful with your signs, okay? All right. Let's look at example G, okay? -2 times row 2 plus row 1 becomes row 1, okay? This is a valid row operation. It's the third row operation. I want to replace row 1, so I take row 1 and I add it to a multiple of a different row, okay? I'm doing -2 times a different row, adding it back to the first row. That's going to replace row 1, okay? So this is valid, okay? All right, again, working with my original matrix, okay? We are not changing row 2. So I'm going to go ahead and write in row 2. It's going to stay 1, -3, 5. Okay. And then I'm going to go do the work out to the side. Okay. So I don't make a mistake. Okay. I'm going to do -2 times row 2. Row 2 is 1, -3, 5. Okay. That's going to give me, if I distribute, -2, +6, -10. Okay. Add it back to row 1. Row 1 is 2, -4, 6. Okay. If I add, -2 plus 2 is 0. 6 plus -4 is +2. -10 plus 6 is -4. Okay. So that's going to become the new first row. Okay. I hope this is making sense to you. All right. One more, part H. Okay. We're going to do -1/2 times row 1 plus -1/2 times row 1 plus row 2 becomes row 2. Okay. This is valid. Okay. If I want to replace row 2, I have to take row 2 and add to it a multiple of a different row. Okay. So this is just straight application of row operation number 3. Okay. All right. So going back to your original matrix, we are replacing row 2. So that means row 1 is going to stay the same. 2, -4, 6. It's not changing. Okay, so 2, -4, 6. Okay, I want to do a little bit of work to get the new row 2. Okay, so what I'm going to do is I'm going to go out to the side and I'm going to multiply row 1 by -1/2. Okay, so that's going to be, if you distribute, okay, you're going to get -1. Negative times negative is positive. This will be 4 times 1/2. That'll be 2. Okay, -1/2 times 6 is -3. Okay, you're going to, so that's -1/2 times row 1. Okay, now we're going to add row 2 back to it. Okay, the original, go back up here. The original row 2, okay, is 1, -3, +5. Now you want to add. Okay, so -1 plus 1 is 0. 2 plus -3 is -1. -3 plus 5 is +2. There is the new second row. Okay, so hopefully this practice with the row operations kind of, gave you a glimpse into how you operate on an augmented matrix. Okay. All right, so now what we're going to do, since we know the row operations, okay, we're going to talk about, how you actually apply these row operations to solve a system of equations.